In this video, I'm going to go over the standard deviation tab. So the standard deviation is a measure of variability. So it represents how different or similar your data points are to each other. So in this example, we have data from two classes, one from a university, and then another one from a community college. So if you look at the data, you can see that the ages in the university class are all very similar. They're all around, 20, 21 years of age. There's not a lot of variability. So there's little variability in this data set. For the community college, there's much more variability or differences among the ages. So we have a wide range of age. So the community class has much more variability when it comes to age. So what is the average for each class? So for our community class, we got 20.33. And again, all of those data points are very close to the mean. For the community class, the average is 30.17. And again, these data points are farther away from the mean. So there's much more variability. So we compute variance and the standard deviation to represent variability. And we're going to do this with the .p version. So remember, when you compute variance or the standard deviation, you have .p or .s. And that depends on whether you're working with a population data set or a sample data set. So for this example, we're just gonna act like this is a population data set. So I have a variance of 0.89 and a standard deviation of 0.94. But what do these numbers mean? So the standard deviation, I'm going to write the definition over here. The standard deviation is the average difference from a data point to its mean. So again, for the university class, the average or the mean is 20.33. So we want to see what's the average difference. So on average, how much are students away from that mean of 20.33? And it looks pretty small. It's going to be about 1. So what we could do is we could compute a difference score for each student. So we could take their age and we could subtract the mean. So we want to see the difference from the mean. So this person is 0.33 below the mean. They have a negative sign. You can see 21, they're 0.67 above the mean. So now what we could do is we could compute the average difference, right? That's the standard deviation. It's the average difference from the mean. And it is 0. And this is just how it always turns out to be. So the average difference from the mean is always 0. And the reason why is because the negative values and the positive values are going to cancel each other out, and it's always going to end up to be 0. So what we want to do is we want to remove these negative signs, right? We don't want the positive and negative values canceling each other out. So what we do is we square the difference, right? If you square a value, you are removing the negative sign. So now what I'm going to do is I'm going to square all the differences, and then I'm going to compute the average squared difference. And I got 0.89. And this happens to be the variance. So the definition of the variance, it's the average squared difference from a data point to its mean. Well, squared differences don't really make sense. It's hard for us to think what a squared value is. So what we do is we take the square root of the variance, and this is the average difference from the mean. And this is our standard deviation. So in order to get the average difference from the mean so that it doesn't equal out to 0, we square it, we compute the variance, then we take the square root of that to get the standard deviation. Obviously, this method was doing the formula. It's much easier to do the function, but I wanted to go over the formula because it helps you understand what these values mean. So let's interpret and give a definition for this value 0.94. So that means on average, a student in the university classroom is 0.94 years away from the class mean of 20.33. So in the university classroom, we have a very small standard deviation. It's only a year, and that's because everyone's very closely clustered around that mean. Everyone's about 1 year away from that mean. Now let's go to the community college classroom. So we're going to compute the variance with our function. We got 92.47 for our standard deviation. I got 9.62. So we have a much larger standard deviation. So larger standard deviation equals more variability or differences. Values are farther from the mean. So let's go through our formula. Let's compute a difference score for each student. We're going to take their age and subtract it from them. Subtract the mean from that. Lock the mean. Copy that down. You can see that everyone's difference scores are much larger than they were in the university classroom. And that's because there's more variability and people's age is farther from that mean. So what is the average difference? Again, this always is going to equal out to 0 because these values cancel each other out. So what we do is we square them. Then we can take the average square difference. That is our variance. So on average, students are about 92.47 squared years from the mean. That doesn't make any sense to us. So what we do is we take the square root. That gives us the standard deviation. Now this is the average difference from the mean. So in the community class, we'll write the interpretation here. On average, a student in the community college classroom is, I think it was 9.64. Let's check. 9.62. Away from the mean, and their mean was 30.17. All right, so again, the community classroom had more variability or more differences, so they are going to have a larger standard deviation. That means that their values are farther away from the mean. All right, so this is it for the standard deviation tab. For the exam, you're going to be expected to know the definition of the standard deviation and the variance and how those values are computed in the sense that, we take the difference and we can square them for the variance, and then we can take the square root for the standard deviation. All right, so that is it for this tab.